Okay, good morning. Yeah, we wanted to talk about critical period for weed control. Now, when we are weeding crops, there's what we call timely weeding. And if there are delays, usually the crop is affected by weeds, leading to reduce the yields. Okay, let me move my slides a bit. Okay, my slides were stuck a bit. Now, the questions which we want to address is how long should whole weeding be delayed before there is crop yield loss? Is it 1 week, 2 weeks, 3 weeks, 4 weeks, 5 weeks, or even 6 weeks? The other question is how long must be a crop be free of weeds to prevent crop yield loss? Is it 1 week, 2 weeks, 3 weeks, and so on? You may find that the current weed control practices under smallholder farming environment may be done at the wrong time, or weeding in the wrong places. There could be too much weeding or no weeding at all. Now let us look at the life cycle of a crop. Number one, there's a period when weeds do not compete with the crop. This is a few days after crop emergence and delays and days before the crop reaches maturity. The second period is when weeds compete with the crop, from 2 to 6 weeks after crop emergence. So if we take the life cycle of a crop, we need to identify these two periods. Now, what is the critical period for weed control? Of course, this is the time when weeds should be removed. It starts from the time when a delay in weed control results in significant yield losses and extends to the time when weed control does not result in significant effects in increasing sorry for the disturbance. Now the critical period for weed control is that period when if you do not remove weeds, you can have a yield loss. As I have described it on this slide, it starts from the time when a delay in weed control results in significant crop yield losses and extends to the time when weed control does not result in significant effects in increasing crop yields. Here I've got a diagram which is composed of two graphs. On the bottom of the graph, we have got time in weeks. Then on the x-axis, we have got the crop yield. Now we have got this curve, which is black, represents delays in weeding, or we can call it the weedy period. So if we come in early, the yield is almost 100%, and it decreases as we delay weeding. On the other hand, we have got the period which is free of weeds, which we can increase, and also look at what happens to yield. It is represented by this red curve. Now, if you increase the period when weeds are not in the field, let's say from 0, 2 weeks, 4 weeks, 8 weeks, and throughout the season, you tend to increase the yield up to almost 100%. Then you can say that as a manager or agronomist, what sort of yield loss can you tolerate from weed competition? It could be 10% or 5%. So we come here and adjust for the tolerable yield loss, or the yield loss which can be tolerated. Then we mark it on the x-axis and draw a straight line across. That line will meet the curve which represents delay in weeding, and we also mark a straight line downwards. That is the beginning of the critical period for weed control. And where this line meets the curve which represents the weed-free period, we call it, that is the end. of the critical period. So these two graphs can actually pinpoint the critical period for weed control. This is the time when weeds should be removed so that we can maintain crop yields. There's a study which was done by Thomas and Van Lindet in 1980 where they tried to estimate the critical period for weed control in soybean. So they've got these two curves, the weed-free one which is red or brown, then the weedy one which is blue. These 2 points, I hope you are seeing them, mark the weed-free period. So if you want to establish the critical period for weed control, you need special treatments. Number one, you need weed period treatments where you have 0, that is no weeds. Then you can vary the weed period from 2, 4, 6 and up to 8 weeks. Then you have another set of treatments, weed-free period in weeks, where you have 0, that is, you are having weeds present. Then you can vary this period, the weed-free period, 2 weeks of weed-free, 4, 6, and 8 weeks. This was firstly proposed by Nieto in 1968, and Zimdar also did some literature review on the impact of such treatments across different crops. Nevik et al. In 2002 revisited these treatments. So just remember that you want to produce this model, which is actually a tool for weed management, because it can locate the time when weeds should be removed. So in this country we have data on the critical period of weed control or for weed control in Zimbabwe. Now from this data or from the studies, it can be concluded that in most cases the critical period of weed control can start from 2 weeks after crop emergence, and it can extend to 6 or 8 weeks after crop emergence. So in Zimbabwe we need to weed or remove crop weeds. Okay, hold on. Yeah. Yeah. Yes. I want to read. I want to read right. Okay. No, it's good. You are very right. Okay. That's great. That is good. Okay. Yeah. No, it's all right. pamwe ndogona kuzokuonesha ine zvimuchini lecture.
It's all right.
Yeah.
We overheard your lecture takamira pano. Patangorwadzikana kuti tikoenda pamwe tozotadza kudzokera.
You are very right.
All right.
Okay. Sorry for that disturbance. I could not avoid these students. Anyway, I was talking about the time when we should remove weeds. It's between 2 weeks and 6 weeks. I mean, stretching from 2 weeks to 6 or 8 weeks after crop emergence. For example, from 2 to 6 weeks in soybeans. This was established by Thomas and Van Lindet in 1980. And even up to now, this period is valid. However, in winter cereals, this period has been hardly determined, possibly because weeds are killed by winter, by frost in winter. This is soybean crop infested with weeds. Now we want to look at the factors which can possibly affect weed competition. Number one, remember, we want to look at the factors which can affect this model. It is really ideal we have located the critical period of weed control, but there are certain factors which can affect this diagram or model. So this is what we are talking about. The first factor is the time of weed seedling emergence, or a period of weed seedling emergence relative to crop emergence. Now, if you have weeds that emerge before crop emergence, you have got serious weed competition, to the extent that this model may not work. We may not actually find that critical period, because what it means is that weeds have to be removed immediately. Now, weeds that emerge or germinate with the crop are also highly competitive, but this model can work here. Weeds that germinate after crop emergence are less competitive. So the model, let's say you establish your crop late in the season, the weeds may not really challenge your crop. The other issue is weed density. There's a minimum weed density which can affect crop yields, what we call weed control thresholds. Probably later, when I find the time, I will need to explain what we call weed control thresholds. But this is the weed density which is required to reduce crop yields. If the weed density is lower than this weed control threshold, then your yields are not going to be affected. But of course, if you increase weed density, you can actually decrease crop yield. So this model depends on the density of weeds which are prevalent in the field. Crop density is also an issue. Increasing crop population may decrease weed populations. So crop density can affect the critical period for weed control. Also, the weed species which are in the field, they have different competitive abilities. For example, it could be Rapoco grass versus Mexican clover. Probably Rapoco grass is more competitive. Pigweed versus blackjack. Pigweed could be more competitive in soybean. So the presence of weeds is a factor depending on the competitive abilities of these weeds. They can influence the critical period for weed control. Let's say you've got a field with weeds which are less competitive, then it may not be critical to remove the weeds. There are also crop species or varietal effects where you have differences in competitive abilities of crops like barley, rye, wheat, and oat. You could also have the same among different maize varieties or soybean varieties. So crops which may tolerate weed competition may suppress weeds, and hence the critical period for weed control may not be a serious issue. Soil and climate factors, you've got soil fertility, low nitrogen, phosphorus, and potassium may have serious competition for nutrients. So if the nutrients are limited, we expect serious weed competition, especially in some of our soils in Zimbabwe. Soil moisture can also affect competition. Drought season can actually make competition very tense. In this environment, if we are having a dry season, we should remove weeds probably around 2 weeks or much earlier. In a wet season, Thomas demonstrated that weeds could be delayed up to 8 weeks without causing any damage. That was in maize at the Henderson Research Station. Also soil pH. At low soil pH, around 4.2, 4.5, there could be serious weed competition in maize, according to Kaganise et al. 1999. Then we've got cropping practices. Time of planting crops is also important. Now, I know we recommend that we should plant early, but during that period, we have the first flush of weeds, which is highly competitive. So weeds have to be removed around 2 weeks. If farmers decide to plow their fields first after the onset of rains, the crop is likely to be subjected to the second flush of weeds which is less competitive, but of course there can be a penalty in yield reduction due to delayed planting. So you might have to look at the balance of how much is affected by delayed planting, how much is affected by the presence of weeds. That is in terms of yield losses. Now, in flare areas like in Chiota and Masvingo, we have maize which is planted around this period, August to September. You may find that weeds do not emerge because of the dry soil surface. So the critical period for weed control may not be an issue during this time because the weeds are not present. You can also affect the critical period by planting patterns and crop density. What we call crop density and rectangularity. For example, square planting can reduce weed competition. In fact, the way we plant our crops can enable us to reduce the impact of weeds. Probably, if you want more information on that, you can visit Martin and Wiener paper on the effects of weed density and sowing pattern on weed suppression and grain yield in 3 varieties of maize under high weed pressure. These scientists are proposing that by simply rearranging plants in the field, you can avoid weeding. So these are the details of their paper. You can read it. But what they are proposing is that the grid was more effective in reducing weed density compared to the rows. And of course it varied across the 2 types of genotype, according to the 2 genotypes. You just have to find out from this paper if you are interested. But what we are saying is that if you can rearrange your plants in a certain pattern, you may reduce the impact of the weeds. So in summary, we need to understand the critical period for weed control in crops. That is, there's a period when weeds should be removed. For example, between 2 and 8 weeks after crop emergence. But this can be variable depending on some of these factors which I have actually highlighted. There are about 8 factors which I talked about. And this period is influenced by a variety of factors, and these are the factors which I have gone through, which affect the critical period for weed control. So this is it on critical period for weed control. Let me come back a bit. Hello, are you still there? Okay. So this is the part of weed competition which we wanted to finish, but I may need to revisit at some point. I will give you a notice so that I can explain what is known as the critical, weed control threshold. Maybe in the lectures which I gave, I did not show on the graphs what is the weed control threshold. So I will have to explain it at some other point. And any questions? Otherwise, we want to move on and talk about parasitic weeds.